In this lecture, I want to discuss categorical plots with Seaborn. A lot of these will be familiar to you, as we've already covered bar plots, box plots, and violin plots in Matplotlib. But there are advantages to using them in Seaborn. For one thing, it's easier to add legends and work with categorical data. Seaborn works on top of Matplotlib, so I'll also show you how to use Matplotlib concurrently with Seaborn to add additional value to your visualizations. This applies to all of the types of plots, not just the categorical ones, so this should be a very important takeaway from this lecture. Okay, so I've imported pandas as PD, matplotlib.pyplot as PLT, and Seaborn as SNS. So I've used the read_CSV method to upload a new updated top 10 countries CSV file. It's saved in the same directory and it contains a sub-region field. So let's discuss bar plots on Seaborn. It accepts an X and a Y argument. You can also pass in a data argument. If you pass in data, you can reference the columns of your data frame by just using the column names rather than indexing. But what's different to Matplotlib is that there's an estimator argument. This is the aggregation, which by default is mean. You can change it to sum or another estimator too, and there are quite a few other arguments. Note ax. That is a common argument across the different plots. It's the axes to use. By default, it's just using the current axes, but if we have subplots, we can just pass in the axes that the plot should be on. Okay, so let's create a bar plot with the region as X and population as Y. So I can just type sns.barplot. X is equal to countries_df, region, Y is equal to countries_df, population. Okay, so it's already a pretty nice format. Unlike Matplotlib, it's already colored by each region. It also comes with error bars, which are these vertical lines. The error bar is by default at a 95% confidence interval, so that means there's a 5% chance that the value of a sample is not within that range. We can remove the confidence interval by specifying none for the CI argument, like so. We can change this to a horizontal plot by swapping the X and Y values, like so. Okay, so now let's add on a data argument, which is the data frame. So we no longer have to specify the X and Y values as the index. We can just reference the column names, like so. Data equals countries_df, and then we can get rid of the index and just have the column names. As you can see, let me just swap X and Y around again. Great. Right now, we have the estimator as the mean. We can change this so that it's the sum by specifying the estimator argument equal to sum, like so. And now we've got the sum for each region. There's also a hue argument. This is used for color coding. And also by default, it provides a legend. So let me use the region field for the hue. So I'll just type hue equals region. And note, if I didn't specify the data frame, I'd have to index this column. And note, we have a legend now. And if you want to prevent the rectangles from being off-center, you can specify the dodge argument as false. And then that will restore that view. So remember to use dodge equals false when you use a hue and it starts to put your bars off-center. That's because Seaborn is expecting there to be multiple plots on the same tick. We can also combine Matplotlib with Seaborn. So let's say I want this to be a 10 by 10 visualization, 10 inches in width and 10 inches in height. Well, I can use Matplotlib and create a figure object that is the size of 10 by 10, and then generate the bar plot using this Seaborn bar plot method. I can also use the PLT legend method and the lock argument to center this legend, so that it's in the center, or wherever you choose, just like with Matplotlib. I'll also change the X value from region to country, so we can see each country and it will be colored based on a region label. So let me type plt.figure and then fig size equals 10 by 10. So that will be step 1. And now the figure size has increased. And now let me use the plt legend method. Specify the lock argument as center. And now we've moved the legend too. And then I can use plt.show to remove this output. And it works. I'll also change this to country. So we can see each country and it's colored based on the region. But note that the ordering is important. If I type plt.legend before I've actually done my bar plot, then it will raise a warning saying there's no handles with the labels. And that's because the SNS bar plot generates the labels after the legend method is executed. So I need to order it from top to bottom. Okay, so now I want to show you something else. If I create two axes with subplots using Matplotlib, I can plot Seaborn objects onto the axes by using the ax argument in the Seaborn plot methods. So let me create two axes, fig ax1, ax2 equals plt.subplots, 1 row by 2 column. I'll make this tight layout. So that should be tight layout equals true. And then I'll do fig size again of 10 by 10. Maybe I'll make that 20 by 10. And then what I'll do is I'll generate a bar plot, sns.barplot, and it will contain x equals region, y equals population, data equals countries underscore df, hue equals region, ci equals none. And then I have to specify which axis I want this to be on. If I just enter this, it will get put on the last axis, which is the current axis. However, if I specifically specify ax1 as the ax argument, then it will be on ax1. And note, right now, these are off center because I've used the hue argument. Preventing this would require me specifying dodge is equal to false. And now they're centered again in a nice format. So let me copy this line. And then change this to country. And then ax1 to ax2. And now you can see we have two plots side by side. So that's just to show you how Matplotlib and Seaborn can be used concurrently. A count plot is basically like a bar plot, except for the aggregation. It just counts each observation. So instead of mean as the estimator, it's count. You just need to pass in either an x or a y value. So let me perform a count on the region column. sns.countplot y equals countries underscore df region. Now we have a count of each occurrence of each region. So Asia occurs 5 times in the dataset. And note, since we selected the y-axis, it's horizontally displayed. If I select the x-axis, it's vertically displayed. So you're already familiar with box plots and violin plots from Matplotlib. You can use the box plot on Seaborn, and it takes similar arguments, and as does the violin plot. I have the documentation with this notebook, as with all the plots that we'll discuss. The arguments will be slightly different to Matplotlib, so have a look. It generally works the same though, but it's easier to work with categorical data on Seaborn. Okay, so I've now imported a new dataset. It's the FIFA 21 player ratings. but it contains only the top 100 players. It's saved on the same directory as this notebook. I want to create a box plot of the overall score, just like I did using Matplotlib. So this field. So I can type sns.boxplot and specify x as players overall. We can swap from the x-axis to the y-axis for a vertical display. You can also remove the outliers by using the flyer size argument and specifying it as 0. So let me change this to y and then say flyer size equals 0. So now we've lost the outliers and it's vertically displayed. Okay, so now let me add on an x and a y axis. Y is currently the overall score. Let me add the league name too, so we can see how the different leagues compare. Doing this on Matplotlib would be quite manual, as you'd have to create a data frame for each league. But on Seaborn, you can do it quite easily, like so. And I don't mind the outliers, so I'll just keep them. X equals players league underscore name. And I can combine this with Matplotlib to increase the figure size and create a figure object. This must come before the actual Seaborn object though. So I can type plt.figure fig size equals 10 by 10. And now it's more clearly displayed. And note, if I do it after, the changes don't get applied. So the ordering is important. Okay, so now let me convert this directly to a violin plot. I can just change the box plot to violin plot. And as you can see, it already comes with a box plot inside of it. And you're already familiar with violin plots from our Matplotlib section, but this time it's split based on the league name as the category. A strip plot can show you all observations from your dataset as dots, so you can see all of the points in a sort of single-axis scatter chart distributed around each category. So I've basically converted the previous violin plot into a strip plot, so you can see by each league where the data points are and how they're distributed. Values at the same data point are horizontally distributed, like you can see here. The strip plot can complement violin plots and box plots too, so let me add on a box plot. And I can just change this to box plot. And to make this clearer, I can actually change the color of the strip plot to be black, so you can see each dot. And now as you can see the box plot, as well as all of the dots, which represent the data points. A swarm plot is pretty much exactly the same too. It's just evenly distributed for matching values, like this. Okay, so now let's talk about the point plot. It shows the mean value. And if you look at the documentation, specifically this highlighted bit, it says, a point plot represents an estimate of central tendency for a numeric variable by the position of scatter plot points and provides some indication of the uncertainty around that estimate using error bars. So essentially, it shows you the mean, along with confidence intervals. It takes similar arguments as the previous plots, x, y, hue, and some other ones too. Okay, so let's do a point plot on the FIFA 21 players dataset. I'll look at the overall scores. So that will be the x argument overall. So we can see that the mean for the top 100 players is around about 87.75, and the horizontal line represents the 95% confidence interval. So let's add a y argument too, which is the player's preferred foot. So we can see that the mean is a bit lower for left-footed players, but there's a longer error bar. This is probably due to the fact that fewer players are left-footed, so the sample is smaller. We can also add a hue. So let me actually change the preferred foot as the hue, and for the y argument, I will add the league name. So we can see in the German Bundesliga, there is a larger difference in average overall scores between the left and right-footed players that make up the top 100. Okay, so these were some plots on Seaborn that can help you work with categorical data. Be sure to review this notebook along with the links